the previous videos, we mentioned about the detailing of the beams. It provides information regarding all the details within the beam in reference to the structural key plan. The information as given in the structural key plan, such as the name of the beam, the location of the beam, the grid line, the dimensions, and etc., should be in line with the structural key plan. On top of that, there will be additional information regarding the conditions of the beam, whether it is continuous, single span, or cantilever. There will also be clear indications regarding the adjacent members, such as the adjacent slab, incoming beams, as well as its supports, such as the columns or stumps. You need to provide the information regarding the reinforcement bar, shear length, lapping length, cross sections, dimensions, and etc. As there are so many informations to be incorporated in the detailings of the beam, you need to make sure that it is neatly presented to the contractors. Make sure there are no overlaying of the text or lines. Remove the unnecessary lines and make sure everything are properly leveled. In these videos, we're going to proceed our discussions with the detailings of the slabs. This again need to be referred with the structural key plan, specifically which cross sections that the detailings are referring to. Clearly indicate the name of the slab, the section of the slab. There will be reinforcement bar, the main and secondary bar. There will be drop and rise, grid line, dimensions, as well as the labels. Let us look at some examples. Normally, you start with the detailing with the slab with the structural key plan. When you need to produce the detailing, you first need to establish the structural key plan. Make sure the structural key plan are properly produced, and then you decide the sections that you would like to cut to be demonstrated to the contractors. For example, this structural key plan, you have 1, 2, 3, 4 units of the buildings, and this building is symmetrical along the length here. That means another 4 units, it will be mirrored along this length. Now you need to decide which cross sections that you would like to indicate to be shown to the contractors so that they know how they're going to produce the slabs. Let's say now you are conservative. You would like to show as many cross sections as possible to avoid the ambiguity or confusions. Then you decided to do the cutting of the slabs, nearly every single span of the slabs. This later it will be provided with the cross section of the slabs. Let us look into the examples of the slab. This is a typical cross sections of the slab. As the building is too large, there will be an extension which cannot fit in within the size of the printed area. There is a symbol here indicating an extension of the section, which in turn will be connected to the following members. And there will be an extension again until the entire section ended. In the case that there are extensions, make sure you label the sections carefully. You know that this slab is referring to section 11, and this will be the continued part of the section 11. Next, we look into the elements of the detailings of the slab. This one is the architecture fixtures as an extension from the building. There will be grid line as well as the dimensions, which should be in accordance to the structural key plan. There will be the names of the floor slab as well as its thickness. The thickness here is 150. It is due to the requirement of the architecture fixtures, which you can measure from the cross sections of the building as given by the architect. And then you're going to lay the reinforcement bar, as you will consider the slab to be continuous. There will be reinforcement bar at the bottom of the midspan as well as the top reinforcement bar at the support. When you provide the reinforcement bar at the top of the slab, you will need to clearly indicate that where does this reinforcement bar ended. Properly level the reinforcement bar in terms of the size and the spacing, which in this case we standardize it to be T10-250. Make sure whichever that you give must be adequate to resist the loads acting onto the slabs. As the slab size is not really large, the provided reinforcement bar is more than enough. When you provide the reinforcement bar, be careful with the main and the secondary reinforcement bar. This is very much dependent on the shape of the slab in terms of the Ly versus Lx. Normally, the reinforcement bar parallel to the Lx, it will be the main reinforcement bar. But when you have the slab putting adjacent to each other, there will be differences in terms of the applications of the main and the secondary reinforcement bar, which in this case, this will be the main and this will be the secondary. However, for this slab, which is adjacent to this, now the main and the secondary reinforcement bar swap, which in this case, you will need to provide lapping in terms of the reinforcements, and the positions where the reinforcement bar can stop need to be clearly indicated. The measurement here is different. It is because the grid line here is actually positioned at the edge of the beam. The distance from the center of the beam, which is the support for the slab, it should be similar. Normally, we don't need to provide double layer of the slab in terms of the reinforcement bar. What is essential is you need to have bottom reinforcement bar at the midspan, and you need to have top reinforcement bar on top of the support. And when they are lapping, you need to clearly indicate the lapping length. Sometimes you may have the main reinforcement bar and the second reinforcement bar similar to the adjacent members. You can actually have the reinforcement bar to be continuous without providing the required lapping length. This can increase the productivity of the construction work on site, where the workers do not need to cut the reinforcement bar and do the lapping. However, if you choose to have the reinforcement bar to be continuous, you need to make sure that the length of the reinforcement bar should not exceed 12 meters. Otherwise, the lapping will be required. Also, beware of the drops as well as the functions of the room, whether it is toilet, having the possibility of retaining water, which in this case, this will be the area for the toilet that you would like to prevent the penetrations of the water through the slabs. Clearly indicate the existence of the drop and you will need to provide additional reinforcement bar. In fact, you need to do proper calculations for you to determine the amount of reinforcement bar in controlling the crack width, which in this case, double layer of reinforcement bars are provided, and the reinforcement bar are more closely spaced. You will need to clearly indicate the incoming beams, which should be in accordance to the size as indicated in the structural key plan. This gives the contractor an idea how the section of the slab should look like. From here, we are able to observe the relative differences in terms of the section. This will be helpful for the contractor to do quick checking, as you know that on site, the grid lines are all imaginary. This will be an important reference point for the contractors in terms of the relative size of the slab as well as the relative size of the beam section. You see at the support here, normally you need to provide the top reinforcement, and normally there are certain length that you can cut your reinforcement, and when the two supports are too closely spaced, the regions of unreinforced area may be quite limited. If this is too close to each other, it makes no difference if you have the reinforcement bar to be continuous. Of course, this will lead to some wastage of the material, but it significantly improves the productivity of the work. Having a little space between the reinforcement bar to have the material safe sometimes is also no guarantee of saving the materials. It is especially in case of any errors during preparations of the reinforcement bar. It is still possible to have the reinforcement bar being wasted. If they are so closely arranged, might as well you make it continuous. Then the member will become stronger. You feel more confidence with the design. This is another example. Maybe we can have a quick look through as demonstrated here. Now the thickness here is 115. The reason is the slabs are relatively small and the buildings are relatively small as well, and we know that the loadings are quite lightly imposed onto the structures. In the case that you need to mirror the sections, there are two options that you can do. You can draw the entire sections. That means you are repeating these sections again starting from here, or you can clearly indicate the mirrors. Make sure it is properly indicated so that the contractors know its meaning. In the existence of the drops, you are unable to have the reinforcement bar to be continued. Therefore, you will expect some bending of the reinforcement bar with an adequate anchorage length to ensure the stability of the slabs. Same goes to the other side, where you have reinforcement bar coming from this side. This is an example of the slab when the supports are too closely spaced together. That if you quantify the required anchorage length, they might clash into each other, or even if they don't clash, the space here it will be quite limited. Might as well you extend the reinforcement bar to make it continuous on top of the slabs. This is the typical design for a single unit slab. Although you know that you can actually design the slab to be simply supported. However, for reinforced concrete structures, there is no definite pin support. Normally, we will also provide the top reinforcement bar at the support to ensure the integrity of the structures. What we see here, The detailing of the slabs can be presented through the cut sections of the slab in reference to the structural key plan, and you need to provide adequate cut section to demonstrate to the contractor in terms of the layout of the reinforcement bar that differentiate which is the main, which is the secondary reinforcement bar. You know that the grid line and dimensions, which may be clear in the technical drawing, however, in the actual situations on site, those are imaginary. Therefore, it would be good of you to clearly indicate the incoming beams as per their exact size, so that it is easier for the contractors to identify which slab is which on site. Mind the rise and drop, as well as be careful with the arrangement of the reinforcement bar. Clearly indicate the lapping length, as well as the anchorage length at the top of the support. Everything needs to be clearly indicated in the detailing to avoid confusions. There is one more thing that I need to mention about the detailing for the slab. Normally, when you do the cut sections, there will be combinations in terms of the horizontal cut sections and the vertical cut section. And in the horizontal cut section, let's say, the locations of the main and the secondary reinforcement bar, where the main reinforcement bar, if it is placed in this manner, that means another sections which is perpendicular to the section, the reinforcement bar, it will be at the opposite arrangement. It is not possible to have two perpendicular cross sections to have the same arrangement of the reinforcement bar. It must be one something like this, and another one will be something like this in terms of the longitudinal as well as the cross sections of the bar. And this you need to be careful, and it is to avoid the confusions, especially when it is not properly done. And these mispositions of the reinforcement bar in terms of the main and the secondary may seem to be minor. However, in terms of the calculation steps, the effective depth of the slab, which is D, varies, and this can lead to a significant difference in terms of the bending moment capacity of the slab. Of course, if you don't want to fully abide to the LX must be the main reinforcement bar, you can actually apply every slab to be in the same arrangement of the main reinforcement bar and the secondary reinforcement bar. That means regardless the LX and LY, both plane will have the same set of arrangement. If you choose to do so, you need to make sure when you do the calculations, especially for this slab, the effective depth D is calculated accordingly, and you need to make sure with the reductions in terms of the effective depth due to you purposely swap the arrangement of the reinforcement bar between the main and the secondary, the slab must pass. This is also applicable, and this might help the contractor to make the work easier instead of so concerned about the arrangement of the rebar in different slabs and provide lapping at the adjacent slab. Either way we do, if you do it in the conventional way, that you observe the LX and LY to determine the main and the secondary reinforcement bar, that should be okay with the contractor as well, because they have been quite used to those. But if you choose to not following the conventional way, which you have decided the main and the secondary, regardless the LX and LY, then you need to make sure you do appropriate calculations, and that will make the sections of the slab to be easier, and the entire slab of the entire floor of the building can be consistent throughout. This is another approach that you can use. In fact, there is no standard ways that you need to fully abide. The bottom line, it will be making sure that the structures is stable and it is clearly presented to the contractor so that they know how to construct the member.